There's another form of expressing an equation of a line, and that is known as Cartesian form. So whatever we derived for this in the previous video, we are going to make use of that and re-express that into Cartesian form. The underlying principle under which this has been built or we are going to derive is that the direction ratios has to be same for any line which are parallel in three-dimensional space. So we're going to start off with the following. So let's consider a point A on the line which is x, y, x1, y1, z1 and having a direction ratios of a, b, c. Now let's consider a coordinate of a point P, right, which is random as x, y, z. So we have derived this and we came up with R is equal to A plus lambda times of P, where R is position vector, of P and A for vector A for A, point A. Anyways, we already mentioned it. So let me continue with this. Now, on expanding it, so what will you get? So we can rewrite them as j cap plus k cap. This is equal to, on the right hand side, we have, so in place of A, we have x1 I cap, then we have the j cap, and then we have the k cap, plus lambda times of A I cap plus lambda b j cap plus lambda c k cap. Right? So further rearranging and all of that. So we have x I cap, or let me just write that. So the RHS will be equal to, if I take I cap out, so we have x1 plus lambda A, plus if I take j cap out, we have y1 plus lambda b plus a k cap of z1 plus lambda c. That's our RHS. And finally, we'll write, let me equating the coefficients of I cap, j cap and k cap. So what do you end up with? X is equal to x1 plus lambda a. So from this we can infer that lambda is equal to x minus x1 by a. Y is equal to y1 plus lambda b, and from this we can infer that lambda is equal to y minus y1 by p, and z is equal to z1 plus lambda c. So from this, lambda is equal to z minus z1 by c. Agree? So in the first, second and third, what is there? What is that we are looking at? We have something common. What is it? Yes, we have the lambda common. So therefore we can equate x minus x1 by a, which is equal to y minus y1 by b, which is equal to z minus z1 by c. And that's why I told all of this is related to our fact that the direction ratios has to be same for lines which are parallel. So since AP and vector B are parallel to each other, the direction ratios have to be equal. So sometimes we can get the direction cosine of the vector B. Okay, this line's direction cosine we might end up getting. And then the relationship will be x minus x1. So same thing. Let me actually not even write it. So same thing. What will change? You have to explain. Yes, in place of ABC will be LMN. That's it. Okay. So that's a small note. And it's your derivation. Yeah, this too you guys have to pause and write.